Hey everyone, welcome back to the channel. In today's video, we are diving into one of the most critical security vulnerabilities in web application, SQL injection. This is something every developer, security enthusiast, and ethical hacker should understand. We're going to break it down step by step, starting with a simple SQL injection demonstration using a vulnerable application followed by automation tool called SQLmap to show you how this works and at scale. Let's begin by taking a look at this vulnerable login page. This is a web application for a fake bank. And as you see, it's not as secure as it claims to be. We've got a standard login form asking for username or password. Now, the vulnerability here is that the application does not properly validate user input, make it perfect target for SQL injections. SQL injection happens when an attacker is able to manipulate the SQL queries that interact with the database. And this login form is where the vulnerability starts. The user input their credentials, and the application sends these inputs to the database to check for a match. However, if the application doesn't properly sanitize the inputs, we can exploit it. As we interact with the application, you see the application logs on the screen. This logs give us a clear view of what happened when we try to log in. Now, let's try entering some basic credentials to start. And we'll enter a random email and password here, expect we're denied, access because the credentials aren't valid. The system just tells us that the login failed, which is a normal response. Now, let's take a deeper look at what happened when we try guessing the password. We'll start with a basic guess and hit login. Notice the login attempt doesn't work. The system isn't letting us in because the username and password don't match any record in the database. Now, this is where things get interesting. If we try adding a code chapter after the password, like for this, we can break the SQL query in a way that the database doesn't expect. Let's take a look at what happens. Notice how we now get an error message. It's crucial. It indicates the SQL syntax problem, which caused the application to break the SQL query, which is a sign that the application is vulnerable. Now, let's use this vulnerability to our advantage. We are going to perform a SQL injection attack instead of guessing the password. Let's enter a special payload. The payload we're using is quote or 1 equals 1 dash dash. What is that? It tricks the database into thinking the condition is always true, so it doesn't even check the password anymore. Instead, it's just logging us in. As you can see, we are logged in with bypass authentication entirely by exploring the SQL injection vulnerability. Let me explain exactly what happened. The SQL query in the backend looked something like this. When we enter password as quote or 1 equals 1 dash dash, the query became assigned from user where email equals quote and password equals quote or 1 equals 1 dash dash. The dash dash part, and then is a comment in SQL. We tell the database to return everything that follows it. So instead of checking the password, the query is always true because 1 equals 1 is always true. This allows us to log in without the correct password. Now, that we manually exploited SQL injection, let's take it up a notch using SQLmap to automate the process of detecting and exploring SQL injection vulnerabilities. It's a go-to tool for penetration testers and security experts, saving you tons of time in discovering and exploring these vulnerabilities. This is a vulnerable site. With SQLmap, we can quickly test and exploit vulnerabilities in an endpoint like the one we've been using. An endpoint is a specific URL or page that communicates with a backend server or database. In this case, our goal is to identify an endpoint that's vulnerable to SQL injection. I show you how to SQLmap can automatically check for these vulnerabilities and even extract sensitive data from the database. Let's start by running SQLmap against the vulnerable page. Here, the basic command to check SQL injection vulnerability in the URL. And in this command, we point SQLmap to the target URL. The dash pass flag automatically answer all questions with the default option, which is perfect for automation. And SQLmap will start testing the URL for SQL injection vulnerabilities. It will prove different parts of the URL and query parameters to find the right place to exploit. Look at this output. SQL map has successfully detected that the artist parameter is vulnerable to SQL injection. It's now ready to exploit the vulnerability and interact with the database. SQL map identifies this is a Boolean-based blind SQL injection vulnerability. SQL map thus is inject a statement that always evaluates to true. When this condition is true, the application continues executing the SQL query without errors, which confirm that we've found a weak point. The SQL map has found the artist parameter is injectable. Now that we know the parameter is vulnerable, let's move to the next step, extracting some data. We can now use SQLmap to extract information from the database. Let's extract all the available databases to get better idea of what we are dealing with. This command asks SQLmap to list all databases on the target system. The dash DBS flag tells SQLmap to enumerate the available databases, and the dash bash flag skip all the prompts. As you can see, SQLmap lists the databases available on the target, including information schema, Aquars. We'll go ahead and select the Aqua databases to see what's inside. We'll list the tables in the Aqua database to explore the contents. Let's run this command. The dash D flag specifies the database Aqua, and the dash tables flag tells SQLmap to list all the tables in the specific database. We know now that the Upwork database contains 8 tables, including artists, user, cards, and others. Let's go ahead and check what fields are available in the users table. Now, let's see what fields are in the user table. We'll run this command to list columns inside the user tables. The dash columns flag tells SQLmap to list the columns within the user table, so we know exactly what kind of the data we can extract. As you can see, the user table contains several columns: CC, name, pass name, and email. We are interested in extracting username and password for this demonstration. Now that we know which fields are available, we can extract the data from the users table. Let's go ahead and dump the username and password columns. With this command, we specify the Aqua database, the user table, and the columns username and password. The dash done flag retrieves the data and brings it to the screen. SQLmap successfully dumps the username and password from the user table. As you can see, retrieve text with text. While SQLmap is an excellent tool for discovering and exploiting SQL injection vulnerabilities, it's crucial to prevent these types of attack. Here are a few tips to protect the application. Use prepared statements and parameterize queries to ensure user inputs are treated safely. Sanitize and validate all user inputs, even if they seem harmless. As you can see, SQL injection is a powerful attack method, but with tools like SQLmap, we can identify and exploit bullets quickly. But most importantly, we need to secure our application against this attack. If you have found this video helpful, please like, share, and subscribe for more cybersecurity content. Thank you for your watch.